Greetings, students. In this video, we will review questions number 11 through 15 of the January 2023 Algebra 1 Regents. Where possible, I will provide two solutions. One will be an algebraic approach, and the second will leverage the use of the TI-84 graphing calculator. Go ahead and grab your notebook and pencil, and let's get started. Question number 11 states, Sunny purchases a new car for $29,873. The car depreciates 20% annually. Which expression can be used to determine the value of the car after t years? The first step is to think about the standard equation of an exponential function, and that is a of t equals a times 1 plus or minus r raised to the t. This amount over here to the left represents the final amount. The a value right here is always going to be the initial amount. And our r value over here is going to be the rate of growth or the rate of decay. We know it's growth when we're adding the value r, and it's going to be decay when we're subtracting. And finally, t represents our time factor. It could be months, days, years. It all depends on what's mentioned in the problem. So in this case, our time factor is represented by years. So let's look at our context clues and annotate our word problem to see what information stands out. If Sunny purchased the new car for $29,873, this looks like it will be our initial amount. And the word depreciate means to go down in value. So we know that we're going to have a subtraction operation happening in our actual function. Let's plug in the information we have. All answer choices have 29,873 in the beginning, and they all have t as the exponent. So the only thing that we need to identify is what information should go in the parentheses. It makes sense that since the car is depreciating by 20%, we would have 1 minus 0.20 in the parentheses. And of course, our initial value, 29,873, would be right outside the parentheses to the left. So if you look at answer choices 1 and 2, where it's just an actual decimal, the correct answer here would actually be 0.80. We should have 0.80 if we're not going to have the 1 minus or 1 plus, so to speak. So that's why we know for sure that answer choice 1 and 2 is completely incorrect. And then when we take a look at answer choice 3 and 4, because answer choice 3 has the subtraction operation, that lets us know that we have the correct answer. This is not really a problem that requires use of the calculator. You really just need to understand how to structure an exponential function and go ahead and plug in the necessary information. Let's move on to the next problem. For question number 12, it states, if f of x equals x squared plus 2x plus 1 and g of x equals 7x minus 5, for which values of x is f of x equal to g of x? This problem wants us to determine when the y values of both of these functions are equal. To solve algebraically, I will set the two equations equal to one another. We're trying to determine the values of x when f of x equals g of x. So let's go ahead and make f of x equal to g of x. Let's do it. So x squared plus 2x plus 1 equals 7x minus 5. Because we have the x squared term here, we know that this is a quadratic function, and the best way to solve a quadratic function is to get all of the terms on one side. So I'm going to subtract 7x, and I'm going to add 5. On the right-hand side, these terms are going to cancel out, and now we have x squared minus 5x plus 6. Now let's go ahead and factor. We have the two x values, right? Because we're asking ourselves what times what gives you x squared, and that's definitely going to be x times x. And in order to factor, I usually answer two questions. What two numbers, when you multiply, you get the C term, which is positive 6, but when you add, you get the B term, which is negative 5. So think about that for a second. It could be 1 times 6, it could be 2 times 3, but our goal is to make sure that when we add the two numbers, we're getting negative 5. So let's try out negative 2 and negative 3. When I multiply a negative times a negative, I can get a positive, or a positive times a positive, I can also get a positive. The reason why I chose the two negatives is because we needed a negative 5 when we're adding. So negative 2 plus negative 3 equals negative 5. So let's fill in our answers. And we are almost there. So this is the factored form of the quadratic. Our final step is to set up a t-table. That's what I like to call it. This expression is letting us know that x minus 2 times x minus 3 equals 0, which means at least one of these factors needs to be 0. So my t-table states that either x minus 2 equals 0 or x minus 3 equals 0. We're going to add 2 on both sides. And now we have x equals 2 or x equals 3. And that is answer choice 4. That is the algebraic approach to solving this problem. Of course, there is also a calculator strategy that you can use as well. So let's head over to the TI-84 graphing calculator. When using the graphing calculator, you need to look at the two functions that are given and enter it into y equals. To solve this problem, we need to take a look at the table of values for both of these functions, and we're going to identify for which values of x are the y values exactly the same. Let's enter the functions. We have x squared plus 2x plus 1. That is our y1. And for g of x, we're going to enter it into y2. We have 7x minus 5. Let's take a look at the table of values. As I'm scrolling up and down, my goal is to identify when the y values are exactly the same. So 25 is not equal to negative 47. 16 is not equal to negative 40. Let's see if it ever gets close. 4 is not equal to 2. Look at that. The y values are the same when x is 2. So the question is, for which values of x are the y values exactly the same? So that is when x equals 2. Let's see if it happens again. Oh, look at that. It happens when x equals 3. So that's how we know that the actual answer for this problem is choice 4, 2 and 3. Way faster solution if you use the calculator, but make sure you understand both approaches. Let's head over to question 13. For this problem, we will not need the use of the graphing calculator. Question number 13 states that Skylar mows lawns in the summer. The function f of x is used to model the amount of money earned, where x is the number of lawns completely mowed. A reasonable domain for this function would be, let's revisit what the word domain means. Domain is the set of x values, which means our input values. And for this problem, that is the number of lawns completely mowed. So I can completely mow 1 lawn or 2 lawns or 3 or 4. I'm not going to mow half a lawn or a sixth of a lawn. It can't be a fraction or a decimal. Let's take a look at our answer choices. Real numbers contain fractions and decimals, so that's not going to work for us. Rational numbers also contain fractions and decimals. Irrational numbers are numbers like the square root of 17 or the square root of 3. Those are going to be non-repeating, non-terminating decimals. Again, not going to work for us. We want the natural numbers. Natural numbers, also known as counting numbers, are the set of numbers that start off with the number 1, and they go up to 2, then 3, then 4, then 5, and it keeps going up in increments of 1 until it gets to positive infinity. Natural numbers would be a good representation of the domain for this function. Let's head over to question number 14. For this problem, we can use the shortcut that I showed you in the previous videos on how to determine equivalence. Anytime you see this term is equivalent to, you can always double check your work using the shortcut that I shared with you on the TI-84 graphing calculator. For this video, we're going to head straight over to the algebraic approach, but please feel free to revisit the previous 2 videos where I showed the very amazing shortcut on how to solve any Regents problem that says is equivalent to. Let's start factoring. The first factoring technique that I always use is the GCF. We're going to check to see if all terms have a common factor. And when I take a look, all of these terms share a factor of 2, but they don't all have a variable x. So let's start off with the GCF of 2. We now have x squared plus 4x minus 5. Our next step is to apply trinomial factoring. Trinomial factoring is letting us know how to rewrite an expression that has 3 terms into the product of 2 binomials. We start off by saying, what 2 terms can we multiply to get x squared? That'll be x times x. Our next goal is to identify what 2 numbers, when you multiply, you get -5, but when you add, you get 4. So just think about it for a second. What 2 numbers, when you multiply, you get -5? It's pretty straightforward that 5 is prime. So the only 2 numbers that really can multiply to get the number 5 in general is 1 times 5. But our goal is to get a -5. That means one number is going to be positive and one number is going to be negative. I want to think about the sum as well. So if I want a +4, it would make sense to have a +5 and -1. +5 times -1 is -5, and +5 plus -1 is +4. So we have x plus 5 and we have x minus 1. This is how we would factor the trinomial. So the correct answer here is going to be answer choice 1. Question 15 states, Ian throws a ball up in the air and lets it fall to the ground. The height of the ball, h of t, is modeled by the equation h of t equals -16t squared plus 6t plus 3, with h of t measured in feet and time t measured in seconds. The number 3 in h of t represents, so in general, we do like to review what each of the terms represent, but specifically, the c term typically is our initial value. We also like to refer to it as the starting point. We also like to refer to it as the y-intercept. So if we're talking about the height of the ball, 3 represents the initial height of the ball in feet. Typically, when solving projectile motion problems, there are 4 points that you need to pay attention to. The point here to the left is the y-intercept, or the initial value. The point at the top is the maximum height. The point here at the bottom is when the ball lands. So that's usually a time. It's also when the height equals 0. Right here is the time that it takes to get to the maximum height. Time to maximum height. And of course, that is our axis of symmetry. So we know that for this problem, we're trying to figure out what the 3 represents. We know that that's going to be our initial value, or our starting point, or our y-intercept. So let's take a look at the answer choices to see which one is the correct answer. Answer choice 1 is the maximum height of the ball. So that's not correct because it would be over here. Answer choice 2 says the height from which the ball is thrown. That looks correct because that's going to be our initial height or initial value. Answer choice 3 says the number of seconds it takes for the ball to reach the ground. So that would be this point over here. And answer choice 4 says the number of seconds it takes for the ball to reach its maximum height. That would be this point over here. So we know that the correct answer is choice 2. Again, for this type of problem, we don't really need the calculator because they really want you to analyze what the numbers or terms mean within the context of the problem. So you have to annotate the problem, make sure you fully understand how it applies to the real world, and interpret the numbers/terms correctly. If you like this video, please go ahead and like, comment, subscribe, and definitely share. I will be completing this entire exam with you guys so that you can get in shape for the upcoming math Regents. I look forward to seeing you in the next video.